Welcome back, everyone, to our interesting journey. So, today we have leveled up. We have gone a step ahead from previous lessons. We've been talking about numbers, numbers, numbers. But today we move on to algebraic expressions and change of subject to formula. So, we will be concentrating on like terms and unlike terms. But for us to know what all this is, let's not waste time and jump on to talk about algebra. And you'll be wondering, what is an algebra? So, when you talk about algebra, we are talking about a branch of mathematics which deals with letters as well as real numbers. So a letter in this case is used to represent a number. An algebraic expression is a combination of numbers and letters using the four arithmetic processes, which are addition, subtraction, multiplication, and division. Okay, so let's have some examples here. Let's say we have 2y. 2y is algebra. We You can see here we have a number and a letter, and these two here, they are multiplying each other. It's like 2 by y. So we are multiplying a number and a letter. So if you remember here, we say uh we have a number, we have here a number or a letter somewhere. Oh, yeah, letters and numbers. So this is an algebra. Or we can have something like this, 3 over a. This is a number divided by a letter. This is a. Or we can have x plus y. This is a letter adding to a letter. Then we can also have, okay, let's write it here. We can have 3 minus x y squared plus 5 over, okay, let's say y. So here you can see here we have 3 is a number, and this number is subtracting a letter, and this letter is multiplying another letter, and then these are adding um, to a number which is being divided by a letter. So that's what we'll be talking when you talk about algebra. So that's what we'll be concentrating on. So now that we know about that, when we talk about algebra, you say we have something called algebraic expressions. So, what is an expression? If you see the last expression I wrote, this one, yeah, this is an example of an expression. So, what is an expression? An expression is made up of terms made up of terms. Okay, so for us to understand what an expression is, we have to know what is a term. So a term is a combination of a of numbers and or means it can just be maybe a number or just a letter or letters using multiplication and division, and get that right, using multiplication and division. So now let's have an example of terms. If you remember, we have an example like this: 2y. This is a term because we have a number multiplying a letter. So here we have multiplication and division. This is and or, because you can choose any. It doesn't have to be all of them. Okay, we can have another one which we say, I think we say 3 over a. This is a term because we have a number dividing a letter. So we have division. Even if we say xy, this one here is a term because they are adding each other. So now, How, if we say these are terms, now what is an expression? So when you talk about expressions now, expressions are terms that are joined using addition or subtraction. Like we have this 2y and we subtract 3 over a. Now, this is an expression. And then we can say 3a uh, plus xy. Now, this is an expression. So now we have terms and we have expressions. And if you remember, I think when you talk about terms, if you remember, before, when you talk about fractions, we talk about putting fraction to their lowest terms. Maybe we have 3 over 6, and we say we can put this fraction to its lowest term, which is 1 half. So now these are terms. So if we have examples of terms, we have this and this and this. So different expressions has different numbers of different numbers of expression as different numbers of terms. So now let's look and see some examples. Let's see x plus y. How many terms do we have here? We have two terms. One, two, because we said a term is a number and or letters. So here we have a letter and we have a letter, and they are separated with an addition or subtraction sign. So we have two terms. What about if we have, um, let's say, 3 over 9? Okay, this is not equal. Okay, 3 over 9, 3 over a, I mean, 3 over a. This alone is a term, so we just have one term. What about this one? 3 minus y squared plus 5 over y. How many terms do we have in this expression? Okay, we have one, two, three, three terms. So now we know terms and expressions. Let's just have an example. Let's say we have 3x plus y over 2. And let's make them 2. Okay, we have this one, and let's say we have 4x squared minus 3 over 2x plus y. Okay, now we have these two here. Can you tell me how many terms do we have here and how many terms do we have here? You can put your answer down in the comments. Let's see who are going to get this right. Okay, so now I can give you 5 seconds, and okay, now this one here, we have one term. Why? Because you remember we these are divided by either multiplication and division, and here we have this one here being separated with a division sign with this. So it's one term, and the same is happening here. We have this being separated with an addition and division to give us and this. So we have one term from each. But this here is just a foundation for us to know, because in the future we will have to go deeper. We have to go deeper. But for us to go deeper, we have to understand the basics. So that's lead us to like terms and unlike terms. So let's go back to the expression we had before. We had 3 minus y squared plus 5 over y. This one. If you look here, we have this 3, which doesn't have a letter here. And then we have this y squared. And then we have this y here. So this expression is made of terms that are unlike. So, what are like? For us to understand unlike first, let's start by like terms. What are they? Like terms are terms that have the same letter. Like if we have 3a plus 5a, we have two terms here and they have the same letter. So if we have the same letter or letters, those are called like terms. So if you have terms like this, you can add them. You can add 3a plus 5a to get 8a. So these are like terms. So what you see here is unlike like terms can combine. You can combine them, you can add them, you can subtract them, and you can also have maybe 5xy plus maybe 10xy. These are like terms because we have same letters here. So we can just add this and we have 15xy. So like I said, like terms, they combine. But if we have unlike terms now, unlike terms like this expression here, you cannot combine them. So when you are dealing with an algebraic expression, you can combine all the like terms. And if you don't have like terms anymore, it's your final answer because it means you cannot combine these numbers anymore. You have reached the, the final part of the expression. Let's have some examples of expressions and see if we can give them we can take them to their like terms. So we say like terms they have the same letter, unlike terms they have different letters. So now let's see, we have 5y plus 3x plus y minus 7x plus 3. Okay, so for now, let's collect all the like terms and bring them together. So here we have like terms 3x minus 7x. And then another one we have 5y plus y. Then we have plus 3. And then here this is x. And then here we have 3x plus minus, this is minus, so we have minus 4x, and here we have 6y, and here we have 3 because 3 doesn't have any other term. So now that we dealt with our like terms, we can just bring this together and bring our expression back. So we have it's good practice for me that if I write numbers, the one with subtraction sign, I will not start with that. So I'll start with this 6y minus 4x plus 3 because this is plus. Okay, so you can write this in any order. Any order, it doesn't have a rule. But for me, I just choose this because I think it's neat to put a subtraction sign between the in the after the second number. Okay, and that is our expression. Now you can see that here we don't have any like terms. Every term is just one. It doesn't have a like term. And another thing, you see, I picked this 3x here and I picked this 7x. But if you look close, I didn't forget to take the sign because this term has a sign. Every term has a sign. So the sign that come before it, that on its left, that is a sign of a term. So if you move a term to a certain position, you have to carry that term with its sign. They are together, just like what we talked about when we talked about addition and subtraction. I think, or yeah, I think then. So the sign, don't forget the sign. Always carry the sign with you. This is not a perfect way to deal with this problem. So, but I just wanted to make sure that everyone understand what we do. So let's even another example, but in this example, we make it look better because as mathematicians, as you do maths, you will become better if you try to find an easier way to get to an answer, but easier and correct way. So now let's find an easier way rather than writing like this. So now we have an expression which looks like this. 5x minus 3 plus x minus 3y uh, minus 35 plus 7y. So what we do is, okay, we group terms that are alike. Okay, that's like this plus x, and then we have minus 3y, this one, plus 7y, and then we have the numbers minus 3 minus 35, and then we deal with this because they are alike. So this will give us 6x, this one will give us um, this one will give us um, this one will give us 4. What is it? Oh, yeah, plus 4y, and this one will give us 38. So now we get to an answer. If you look, this one is easier than the one we had before. Okay, but we can even do more if you are deeper into understanding. You can even erase this part here because you can just look at this 5 and this, and you know already that from here I can get this, and you look from this, it's going to carry its sign and this, and not from here I'll have this, and from here I'll have this. Then you just eliminate this part, you just come from here to here. That's another way. But if you are still trying to understand, it's the best to bring them together, and then you calculate the answer slowly until you get it, and you start eliminating unnecessary stages. Okay, and now let's have another example which is a little bit different. Let's say we have 7 minus, but now we have brackets, x minus 2y plus 3 5x minus 2. Okay, so now we have this. How do we deal with this? Okay, let's say we talked about BODMAS before, so we just deal with BODMAS, brackets first, right? But the problem is inside the brackets, we don't have like terms, so it's like we cannot solve this. So what do? We remove the brackets first. We remove the brackets. So if you look outside the brackets, on the left, we have a number there. So this one we have minus, but this is minus 1. And here we have plus 3. So you multiply, this means this bracket is being multiplied by minus 1. And this bracket is being multiplied by plus 3. So you multiply every term in the bracket with the number that is on the left of the bracket. So this will give us 7 minus 1 multiplied by x, we have minus x, minus 1 multiplied by minus 2y. Now we have plus 2y. And then here we have 3 multiplied by 5. We have plus 15x, and then here 3 multiplied by 2 minus 2. So here we have minus 6. And now we have an expression, but this expression has some like terms. So now let's try not to bring them together. Let's just jump to the stage where we just write our answer. So first we say minus x plus 15x. Here we have 14x. Okay, our equal sign here. Then we will say mm, for 2y, we don't have any y. We just have one y. So here we will say plus 2y. Then minus 6 and 7. So it's 7 minus 6. Then we have plus 1. So our answer is this to its lowest term. So now you can see that our answer is 14x plus 2y plus 1. And that's our final answer because now we don't have like terms. So our answer will go down until we don't have like terms. The same as when we're dealing with fractions. If you remember, we will stop when we don't have any factors, like we have uh, maybe 9 over 10. This will be the final answer because we don't have vectors that can get into 9 and 10 at the same time. That's the same concept with algebraic expression. If you don't have like terms anymore, it means this one will be the final answer. So that's all on our introduction to algebra and algebraic expressions. So you can you can practice. Oh, sorry. You can practice with this expression. Try to simplify these expressions and see if you can get to the correct answers. And like always, if you have questions, you can ask in the comment section. And if you are willing, you can put your answers in the comment section and I'll check to see if your answers are correct. But for now, we will stop here and practice more. Remember, practicing more will make you perfect. Practice makes perfect. So if you don't understand, you practice more and more and more. If you are really stuck, just comment. I will make sure I try by all means to respond to every comment, all those who have questions. So for today, we'll stop here and have a good day, good morning, or good evening, wherever you are. And bye bye.